my students, on the board is a practical application of what happens during the transmission or supply of electric energy. Some electricity always gets wasted along the cables in the course of transmitting or supplying it from one place to another. The supplying cables assimilate these fragments of electricity to themselves and becomes hot. After some time, they give it out as heat to the surrounding and becomes cold again. Physics calls such electric energy dissipated or wasted energy because they never did any useful work in the cables nor get to their destinations. The question on the board buttresses this that I just said. The question says, electricity is supplied to a school along a cable of resistance 0.5 ohms with the maximum current drawn from the mains as 100 amperes. The maximum energy dissipated as heat for 1 hour is. The question is telling us that a certain school is being supplied electricity, and the cable, which is the wire that is supplying the electricity, has resistance of 0.5 ohms and is drawing from the mains, which is the socket where it is getting the electricity from. It is drawing from the mains 100 amperes current. Now the question asks us, the maximum energy dissipated as heat for 1 hour is, which means what is the highest energy that is dissipated or wasted away as heat during the course of supplying this electricity to this school? As I've just tell us now, during the course of supply of electricity, some of this electric energy that are being transmitted waste along the cable. Yes, they waste on the cable of the supply and they go out as heat, as dissipated energy. We call them wasted energy. So this question is asking us, what is the highest, the maximum energy that is wasted or during the course of supplying electricity to this school? Let's solve it. Right solution. And I write energy dissipated. Energy dissipated is equals to what? I would like us also to know that the cause of this energy dissipated, or the reason for this wasted energy, is that the material component of this cable resists the current from flowing freely. Yes, the material component of the cable offers resistance to the flow, easy flow of the current, thereby assimilating some of the current to themselves. Yes, taking some current to themselves and wasting it on the surrounding as heat. Therefore, our energy dissipated now would be current flowing in the cable square, and the R, which is the resistance offered to that current flowing in the cable, multiplied by the time that it takes to supply the current, thereby energy dissipated is equals to I square RT. This is the formula we are going to use now to get this energy dissipated. Let's continue. What do we do next? We substitute the values, the data given to us in this question into this formula. I start like this. I write this thing again. I say energy dissipated. Energy dissipated is equals to I. What is our I? Which I say stand for current. They give us any current here. They tell us that the current is 100 amperes. Maximum current drawn from the mains as 100 amperes current. So I substitute 100 here. 100. Don't forget that this I, which is current, has square. Therefore, this 100 will also be square. According to R, which is resistance, did they give us any R? Yes, they give us 0.5 ohms. Stand for resistance. So I will write times 0.5 ohms. This 0.5 ohms. Okay, the last one is T. Time. What of time? Did they give us time? Yeah, they say for 1 hour. So our time is equals to 1 hour. But don't forget that hour is not the standard unit of time. Therefore, we convert this 1 hour to second, which is the standard unit of time. So we have this one times 60 times 60 again, because we are converting from hours to second. So to take 260s. So what do we do? Let's evaluate it. I start from the first one, which is 100 square. I evaluate it. Say 100 square will give us what? 100 square gives us 10,000. So I write equals to this 100 square become 10,000 times 0.5 times 1 times 60 times 60. Okay. What do I do again? I evaluate here. Lastly, I evaluate it. I say 1,000 times 0.5 times 1 times 60 times the other 60 will give us what? 18 million. Give us 18 million. Plenty energy. Is dissipated to 18 million. 18. 1, 2, 3, 4, 5, 6. 18 million. If we don't want to go with all these zeros, we convert the number to standard form. So it will be equals to this one, put point, write 8 times 10 raised to power. 10 raised to power what? Wash out. 1, 2, 3, 4, 5, 6, 7. This is where the point is. So it will be 10 raised to power 7 joules. Do you understand? So today we have learned basically 2 important things on electricity. First is that electric energy are dissipated as heat during the course of electric supply or electric transmission. And the second is how to calculate such dissipated energy. I hope you understand. Thank you for watching.